Section 1.7 is an introduction to perimeter, circumference, and area. And this is really just an introduction. A lot of this stuff you guys have seen before. It's not going to be new material. We're going to be stretching this a lot further next semester when we really dive into area and perimeter and circumference of things too.
Yeah, and this is just to kind of remind you of some formulas that you're going to see and how to use them. Again, to hit on Miss Hochraby's idea, it is a little bit of a review, so hopefully not a stressful thing for you.
Right. And let's just start with talking about the parts of a square and how do we know it's a square, because I think that's kind of important too. Ms. Palermo, what are some things that we know about a square?
Well, first thing I think about is square has 4 congruent sides.
Okay, so I'm going to go ahead and put my little tick marks on here just to remind me that we have 4 congruent sides, and there's something else that makes a square unique.
So the next thing is 4 right angles.
Exactly. So just when you're looking at a picture, to know that it's a square, you would have to know those properties, or they would have to tell you that it's a square, and if they tell you it's a square, we do know those properties. So when I'm looking at a square, let's real quick before we start diving into what these things are. Perimeter, just to keep in mind, perimeter is always the distance around an object. So it's if I took all of these pieces and took this two-dimensional shape and laid it all flat out, that would be the perimeter. If I take a piece of string and I wrap it around that shape, that's the perimeter. It's a distance around. Circumference is basically the perimeter, but when we're talking about a circle. So we'll get to that in just a little bit. And then area is filling up the space inside of that shape. When you're talking about area, notice that area is two-dimensional. Your area's got length, it's got width, there's more to it than just a distance. So when we're talking about area, because you're talking about those 2 dimensions, don't forget that that's when we want to have our units squared. And when we talk about perimeter or circumference, that's just a length, so these are just going to be units. So just something to kind of keep in mind when you're looking at these with thinking, is it one-dimensional or is it two-dimensional?
Yeah.
Okay, so tell me what you know about the perimeter of a square.
Okay, well, again, Ms. Hochraby said it's the distance around the figure, so another way of thinking about it, since a square has sides, we can add up the sides, and if all the sides are the same, we're basically adding the same side 4 different times. Let's label the side S, just for side. So the perimeter for capital P would be the S plus S plus S plus S, or just 4S. I like that way better.
I like that way better too. Now, a lot of people are probably thinking back to rectangles and some things we know. There are other ways that I could have written this as well instead of just side length. But with a square, we know that all the sides are the same. So that's exactly what I do too. I just say it's 4 times whatever that side length is going to be. All right, let's go ahead and let's talk about area for a second.
Okay.
Because when we're talking about the area of a square, how do we make up all of the space inside?
Well, something I know that you're probably thinking about is a lot of times square and rectangle together is kind of length times width or base times height. But since we labeled the length and width, they're both S's, so we're taking S times S. Now, would that be 2S?
Wouldn't be 2S, that'd be S plus S, so it'd
be S squared.
Yeah, so the area is that side length squared. Awesome. All right, now let's talk about the perimeter of a rectangle, because rectangles and squares are very similar. In fact, before we do, let's make sure we know the difference. So what are the properties that we know of a rectangle?
Okay, well, I'm going to start with the similarities of a square. It has 4 right angles.
You've got it. But then what's different? Why is this not a square?
All sides don't have to be congruent, just the opposite ones. So the opposite sides there and then there.
Wonderful. So can I call all these side lengths just S now?
No. You got to label them differently. So you got to have 2 variables. Sometimes they use length and width. I think our book uses base and height.
Yeah.
So
either one would be fine.
We'll just kind of be consistent with the book, but length and width is the same thing.
Yep. Now, when we're talking about the perimeter, again, that's the distance all the way around that shape. So now I want to do what?
Well, I have a B for my one base. I have an H.
But that only gets us halfway around.
I have another base. and then I have another height.
Right, because we know that, yes, this is a base. This is also a base because they're congruent, and this was a height. This is also another height. They're congruent. So, yeah, b plus h plus b plus h. There's another simpler way I could probably write that.
I would like to write it because I combine some like terms 2b and 2h.
Now, I'll always have somebody ask me, could I have said 2 times the quantity of b plus h? Sure. That's just going to require you to distribute those, so I usually don't leave it that way. I usually leave it as 2b plus 2h. Okay, so let's talk for a second about area. This is usually the one that most people can come up with off the top of their head.
Base times height.
And base times height. You've got it. All right. So there's squares and rectangles. Similar ideas, not too crazy. Now, for a triangle, this is going to be a little bit different because now I don't have necessarily congruent parts unless it's equilateral. Or if it was an isosceles triangle, I'd have at least 2 congruent parts. So can I guarantee that I have any things that are in common?
No, because it could be scaling. Could be all congruent or non-congruent sides. So all we can do with perimeter is just add the 3 sides together.
Add the 3 sides. I'm going to call them sides A, B, and C for right now. So that perimeter would just be
A plus B plus C.
Okay. And that's as simple as we can get with triangles unless we have a more specific type of triangle that we know. What about area of a triangle? Do you remember that formula?
I think it's 1/2 base times height.
You got it. Now, with a triangle, that's a little different because what are we calling our base and what are we calling our height? One thing that we need to be aware of is any side of that triangle could be considered its base. What makes it a base is it's got to be perpendicular to the height. The height is also called an altitude, is going to be going from a point, one of the vertices of your triangle, and it has to be perpendicular to that base. So if I drew in, and a lot of times we draw it with a dashed line because we want to know that it's not an actual segment of that triangle, one of the sides, but we know that it is perpendicular to its base. So the way that I've drawn this triangle here, drawn this height in, we know that what has to be the base?
Side C.
Side C. And then we would just call this maybe H for height.
Okay.
Now, what if I had an obtuse triangle here? Ooh, that's pretty
great
ugly.
drawing. That's so great.
Thanks. And what if I had drawn an altitude out here? Can I do that?
Yeah.
Because it's still going from that vertex, from that point, and it's perpendicular to a base, but notice, what is it perpendicular to?
Well, like you said, a base is an actual side, so that side right there would be the base. We can label that B, and then that would be the height.
You got it. So just something to be aware of. On this triangle, I also could have drawn a height this way.
So the height can be inside the triangle?
The height could be inside or it could be outside. What if it was a right triangle?
Okay, what if let's say the base that we're using is like that vertical side.
The vertical side?
Uh-huh.
Okay, so let's call this our B.
So the height would have to be the other length there. Yeah.
Yeah, because as long as that height is perpendicular to our base, in a right triangle, the height is on the triangle. The height is one of the sides. And in obtuse triangles, sometimes you'll see that height outside. Sometimes it can be inside as well. If it's just a acute triangle or, most triangles you'll see the height inside. But don't be thrown off if you see a height that's outside.
And so the question is how do you know which one you're going to use? Well, it just depends on the picture. If it's easier to, use the in that obtuse triangle, if it's easier to use the height that's outside because they're both labeled, it depends on the base. I think it all depends on which base that you're going to be using too.
Yeah, and just always know that if they draw in one height, then whatever that height is perpendicular to is your base. All right, let's move to circles. For circles, now we can't talk perimeter. We call it the circumference. So that's where that word is coming in. It's just like a perimeter, though. It's the distance around a circle. Now, do you remember that formula?
Oh, gosh, I don't know. I know it has something to do with pi, right?
It does have something to do with pi.
I do know it deals with radius. So
let's talk about that for a second. What's a radius of a circle?
Okay, radius goes from the center to a point that's on the circle.
Okay.
So, circumference. I know there's a pi and an r. Is it pi r squared?
It's the other one.
Oh, I'm saying area. 2 pi r.
You got it. And one way that I always remember that, I'm going to go ahead and write up the other formula that you said. Area of a circle is pi r squared. One way that I remember the difference, I know they both have a 2, a pi, and an r. It's just a matter of where that 2 is. Notice here that 2 is a square. In area, we talk about units squared. So that's why I always remember which one goes with that square. So they'll both have a 2, a pi, and an r. It's just a matter of, is it a big 2, that it's an actual 2, or is it a square? So when you have a unit squared, it's a squared.
Isn't there another way to talk about circumference?
There is. Actually, do you remember another measure that we could label in this circle?
Well, the other thing, radius involves diameter.
Yeah. If I draw in the diameter goes from one point on a circle to another point through its center. So we know it's basically 2 radiuses together. That's called our diameter. And so instead of saying 2r, I could also call that circumference pi times
diameter, because there's 2 radii that make up 1 diameter.
Absolutely.
All right, now this slide is actually in your book, so it's just a kind of restating some things we've already discussed, but we're going to continue dealing with. You know, a big thing in any kind of math is we're problem solving. So these are just some things to kind of think through, process when you're going through it. Notice the first step says, ask yourself what you need to solve. I think that's kind of a big deal because, you know, there's been examples that we've done where we found X, but that wasn't the answer. So you got to make sure you know what you're trying to find, because if you don't, then there's no point to it. So make sure you know what you're doing. It says draw a sketch or write a verbal model. We've talked about this. Making sure you kind of get a visual. A verbal model, kind of write it out in words, what we're dealing with.
Or sometimes we'll write out, like, for example, our angle addition postulate. The measure of angle 1 plus the measure of angle 2 equals the measure of angle, I don't know, whatever, A, B, C.
Yeah.
And that right there is a verbal model.
Exactly. Again, this is all to kind of get us processing through. Step 2, it says label sketch with facts. So after you draw the picture, sometimes you gotta label. Like we've labeled angles, we've labeled segments with their measures or the measurements that were given. Step 3, choose definitions, theorems. Haven't talked about this yet. We'll talk about it. Formulas, which we've done today, and other results that you need. You know,
throw the word postulates in there too.
Yeah,
that's important.
I think that's true. I'm not sure why they don't have that in there. Any type of rule that we know, but we talked about this a lot of definitions this chapter. Those key words are going to help us know how to go about the problem as well.
Absolutely.
This should be step 4. Step 5.
That's funny.
Reason logically to link the facts. Of course we want to be logical about it. We want to think about through it, not just kind of get some random answer and it doesn't make any sense. You know, really, you know, try to make sense of the problem.
And take your time.
Take your time, exactly. And it says write the conclusion that answers the problem, then check your work. So, you know, get a conclusion. If you have to explain yourself, write down the explanation.
And that's another one of don't just stop at X. Make sure you're writing a conclusion.
Go back
that
to this right
the
here.
Problem exactly.
And then check your work. We've stressed that too. That's a great way to know, did we do it right? Why do all this work for a wrong answer? So we want to make sure we actually did it right.